So, good evening, everyone. Today we are going to solve height of laziness problem, which is another challenge in the Hyderabad-based quarter practice set 2. So, the problem statement is very concise. So, it states that Mr. is a software engineer who is lost in a jungle. He has a map with him, but he is very lazy to look into it. Your task is pretty simple. Help Mr. to come out of the jungle. It might seem simple, but yes, it is, of course, but if you know the concept of backtracking and also if you know the concept of recursion or stacks, you can solve it pretty easily. But in order to solve, you need to take care of few constraints we will see later. So the directions in which Mr. A can move is north, east, south and west. So he cannot move in northeast direction, means he cannot move in slant direction like northeast or southeast or northwest or southwest like that. Only in four direction, northeast, southwest. So the input format is first line denotes the number of test cases t and t lines follow. First line of each test case has a single integer representing the side length of the jungle. Means you need to assume that the jungle is square shaped, so that if side length 5 is there, so the jungle is 5 by 5 square. So a matrix is given in the following line, means after the size of the jungle, which represents the map of the jungle. The map contains the following. So the matrix, which is essentially the map of the jungle, which mystery is lost, has only 4 types of entries. One represents that there is an obstacle. So if there is an obstacle, obviously mystery cannot move in that direction. So the direction gets blocked, and if it is 0, then there is no obstacle. Means mystery is free to move in the direction where 0 is present. And A represents the correct position of mystery. Mystery can be anywhere in the jungle. He might be in one corner. He might be anywhere middle, anywhere in the matrix. X represents the exit of the jungle. Like if A reaches X, means it is success, you have solved the problem. So if for each test case you need to output, means in the given jungle, if A is able to reach X, it's like a maze solver. If A reaches X, you need to output true, and in any possible case A cannot reach X, means it is not possible, that time you need to output false. And note the case sensitive, means you should not output true with lowercase t. That would result in failure of a test case. So be cautious about the output format and also the input format. So here is sample input. So they gave 2, so t equal to 2, that is test case are 2, so we'll have 2 test case. This entire thing is first test case and this entire thing is second test case. So 4 represents the size of the jungle as stated in the input format. So 4 by 4 jungle you will be given, and if there is a 0, obviously Mr. A can move in this direction, and if there is a 1, Mr. A cannot move in this direction. So you need to take him to X. Looking at this problem, it is easy. You can see, like, Mr. A can reach X easily by looking at the figure you can state, but you need to figure out writing code, because few matrices will be very large to solve manually. So that is the reason why you need to write a code which takes an input as a matrix and all these constraints, and which solves and which says true or false. Consider this case. You can see in any of the possible direction Mr. A cannot reach X. Notice that you should not move cross direction, you need to move only in downward direction. So in this case, in this test case, you need to output false. So before beginning, let's try to find out the idea behind the problem. Suppose the side length of the jungle is 4. In the first test case, so this is the given test case. So Mr. A can move in left direction. If you move, suppose left direction, yes, he can move. He can move in downward direction, no, he cannot, because 1 is present. If he moves in right direction, yes, he can. So there are many possible ways how to approach this problem. So this is a classical case of, it's an application of stacks. So we know that stack is a data structure which is a first in last out list. Popularly called as philo, or you can always also call it as LIFO, means the first element to enter into stack is the last element to leave. So if you solve in C++, you'll be given the stack data structure by the STL if you include the stack header. But the idea here is why do you need to use stack if recursion provides you with an implicit stack? Recursion always is carried out by an internal implicit stack which the program maintains. Suppose you call a function suppose a function A calls A after a few certain lines of code, it calls A. So again this function call gets repeated. So in a stack, first you push, suppose consider so this is not a correct diagram, but yes, we can do with it. So consider this is a stack. So initially when you call A, it will be pushed in the stack, call stack, and then when you call in within A, if you call another A, or essentially B, if you call even B, so the B gets pushed into the stack. So again, if you call another function, it gets pushed into the stack. So program maintains an implicit stack. So if you use recursion, you don't need to explicitly use C++ to use the STL. It's up to the decision of the programmer. He can implement anything as far as he doesn't run out of time limit. So let's solve this problem by using recursion. So recursion specifies, the basic idea is, suppose if you have the position of Mr. A, say suppose Mr. A's position is x comma y in the matrix, here Mr. A position will be x is 0th row and he is in first column. So initially Mr. A is in that direction, and what is the goal position? Means the end values of x and y, or you can say goal values, goal x and goal y, which is 0, 1, 2, 3 and 2, 3, 2. So you need to check whether 0, 1 can go to 3, 2 by following this set of constraints. Means you can move only northeast, southwest, you cannot move in slant direction. So how to implement that in program? So you use recursion. With the help of recursion, you call when you're in, suppose a function f, which is called with x and y. You need to check whether this is x and y, right? So you need to check whether A can go in all the 4 possible directions. Since A is here, you can only see 3 directions. North he cannot go because there is no space here. A is here, so he has no north because it is out of bounds. He has only east, south and west. So he can move only in 3 directions. One direction is restricted by the array size. So suppose consider if Mr. A is here. Then Mr. has 4 possible directions, but he cannot move in one direction. So we got 2 constraints. Mr. A cannot move when there is a 1, and Mr. A cannot move when his position after he moves goes out of bounds. This second test case is same as like when Mr. A is here, he can move only in 3 directions. Means only 2. One is he cannot move, and another one is north is ruled out because this is 0th row, and when he moves above, it becomes -1, and that is an invalid index into the matrix. So these are the 2 constraints. So let's name the constraints as C1 and C2. So you need to check all the 4 directions. Means if Mr. A can go northwards, So recursion uses the idea like suppose you're at this position and you're going to move left. You don't know you say the function from 0 can you reach x. You ask the function I'm at a, so in order for a to reach x it must have a path from its left or down or right or north path to reach x. So in that way if you say a, if you go left first, if you go left initially, you say left is 0, so it's possible to go there. So you say if 0 can go to x, so if you call 0 function call, then 0 will again recursive call its left is not present, so if it will check all other possible direction where 0 is there. So 0 is there in downward direction, you say can from down can I go find a path to x. So similarly 0 will also call it recursively all functions. So let's see here. So if Mr. I can go north implies the constraints Mr. I can go north and C1 doesn't hold. Like this constraint should not hold C1 and C2. C1 and C2 doesn't hold because if he can go north and that north position should not be a 1, because if it's a 1 it's an obstacle, it should not move, and if 1 goes out of bounds it should not move. So C1 and C2 doesn't hold and Mr. A can go north. So when he goes north you call, so essentially it's going north means you need to decrement x by 1 and y remains the same. Similarly in east also after checking constraint, now he wants to go east. East is essentially right direction, so you're incrementing the y of the matrix. Similarly if he wants to go south, you should increment x, since he is going downward direction which is opposite to north. And if he goes left, sorry that is west, you need to decrement y. So these are the recursive function call. F of x minus 1 comma y will again be a recursive call to the function itself, and from there again you will check for directions. So to better understand, let's trace the function. Suppose you call f, so our directions, our order of direction, let's go from clockwise direction, that is from top, then right, then bottom, then left. So this is your choice, you can go from left to right or any direction, but I'm taking clockwise manner. So from Mr. A's position, suppose Mr. A's position is x comma y. So from Mr. A's position you need to go in all these directions and check whether at least any of the direction results in a path to x, because you are not asked to find the shortest path, you are asked to find a path exists or not. If it exists you say true, it's like a boolean value, true or false. So from if initial position of Mr. is x comma y and if you want to move in north direction, so initially Mr. is here and he cannot move towards top because it's out of bounds, so top is ruled out. So you'll check whether he can move right. It's ruled out. Then you'll check whether can he go right. Yes, he can go right because 0 exists. So as soon as you can go right, there will be a recursive call to go x comma y plus 1. Now this x comma y plus 1 will also check again from top, right, left, bottom. So from here, can he go right? If Mr. is here, can he go towards top? No, because it is out of bounds. So top is again rolled out. Now we'll check whether can he go right. What happens when you go right? Can he go right? No. Why can't Mr. A go towards right? The reason is there is a 1 in, the reason is there is a 1 present in the matrix, so it's an obstacle. There is a 1 means it's an obstacle. So that is the reason why he cannot go. So even right case is ruled out for this. Now we'll call bottom case. So he can go bottom, right? If Mr. is here, he can go bottom since it's a 0. So you go bottom. Now again, you won't check left case because you're going down. So that is a recursive call. Other cases won't be checked. When you go bottom, so what is a call when you go bottom? From x comma y plus 1, you're going down. When you're going down, you need to increment x, because from here you're incrementing x, y value remains same. So from here you'll be calling x plus 1 comma y plus 1. So this is relative to this Mr. is original position, not related to this. If it is related to this, then it will be only x plus 1 comma y. So this function call x plus 1 y plus 1 is related to initial position of x plus 1 y. If you have to go bottom from x comma y plus 1, if you treat it as suppose say a comma b, then you'll be calling a plus 1 comma b. Okay, now you're at this position, that is you're at here. Now again from here you'll check whether you want to go top, but if you check top, you can go top, but wait a second, if you go top, you're visiting the function which you have already visited. From here you called this, but from here you should not go to the path we have already traversed. Like suppose, then if you don't keep a check, you'll be moving like from this position x comma y plus 1, you will go to x plus 1 comma y plus 1, and since top is 0, you'll go there. So you need another data structure in order to keep track of your path till now. Suppose let's call that data structure, let's use array data structure, and let's call it visited. So visited array will keep track of our path. So from starting at A, you will keep track of your path, means I moved here. So whenever you before calling the recursive calls, you will check whether I have already before going towards top or towards right or towards bottom, you won't only check whether there is a 1 or whether I go out of bound or not, but you also check whether I have already visited the path or not, because from here if you go down here, and from here you cannot go up because you already visited it. I hope you understand why we need the visited array. It will be clear while we, don't worry, it will be clear as we go further. So we need to keep track of it. So in visited array, so here we keep the track of paths. So x comma y is visited, right? In the first case, x comma y is visited. So we will go top, it's ruled out. You go right, yes, you can go. So next thing, when you call this, you need to make that visited also true. That is, you must not come again here. X comma y plus 1. This is the second call. After this call, you need to go. You'll go towards bottom. That is here. Now what is this? It is x plus 1 comma y plus 1. Now here comes the use of array, visited array. When you're here, when you again call top element, it is 0. But since if you don't maintain visited, you will be going there. But you will maintain visited. You'll check every time. If you want to go top, we'll check this, whether I visited this top element. What is this top element here? X plus 1 x comma y plus 1. This top element is already visited, so I should not go there. So what will write in top? I already visited it. So instead of going top, you will check whether I can go right. If you want to go right, there must be a 0, but it is 1. So you cannot go even right. So we'll check whether can I go bottom. you're following this strict order, because once you write code you cannot change it. If you want to go bottom, there's a 0. Yes, I can go. Now after when you go bottom, you need to add path. Which one you need to add? You're going bottom, so you need to increment x. So this is already in path, means our till now path listed is a 0 0 and 0. Now we are close to x. Let's see what happens. Now we are here. Now again we don't go directly to x. We specified we go to top first. So we'll see whether top is visited, and we'll see all the constraints. So basically there are 3 constraints here while we are moving. So in order to be clear, I'll write down here. So we have 3 constraints. So what are the 3 constraints? First one is array must not go out of bounds. So that's obvious. You should not go out of bounds. If you go out of bounds, when you access that matrix, like matrix of a comma b, and either a or b is out of bounds, then obviously your program will experience a segmentation fault. Now the second thing is you should keep track of your path, so that you don't keep visiting the same path over and over again. Like in this case, if you don't keep track of the path, according to algorithm we go top again, so it's a waste of time. Means you won't reach destination if you keep moving between this 0 and this 0. So obviously you need to keep track of that path. So what is the third constraint we have kept? Yeah, and third constraint was the obstacle constraint. So if there is an obstacle, you should not go. So these are the 3 constraints you need to keep track. So the algorithm is very simple. While you reach, until you reach x, you need to keep track of all these things. You need to go in this order: top, right, and bottom, left. You can go in any order, but you need to make sure that if you are here, you need to check all the 4 directions, because those are the 4 directions Mr. A can move. And before moving, you need to keep track of these constraints. I hope it is clear now. Now let's complete our tracing. When Mr. A goes, once you reach I reached X, which is the exit of Django. So you reach the exit of jungle. So what do you need to do when you reach the exit of jungle? Simply return from the function saying I return true. So when you return true, every function call, it pops out of the call stack automatically, because function has returned. Similarly, you won't check all the test cases, because each test case must be kept in a separate if, like if else. If top has a path, you don't need to check the right, bottom, left, since they are not asking all paths. If you find at least one path, you need to return back. So since first is the number of test cases, let's scan test cases. Now we need to loop until we end number of test cases. You need the next input given to you is this n, which is the size of the matrix. So let's call it n and scan it. Now you scanned even the n variable. Now the next thing they give you is matrix. Now here one more thing you need to keep in mind is that this matrix is comprises of integers as well as characters. Since 0 and 1 are integers, of course you can treat them as characters too, but let's treat them as integers, 0 and 1. And a is a character, so 0, 1 are integers and x are characters. So how do you read this kind of a matrix? If everything are integers, you'll take it into an integer matrix. Everything is character, you'll take it into character matrix. Now you don't know where Mr. A position will be and where Mr. X position will be. Sorry, exit of the jungle will be. So the better idea is to read character by character and place in an array by applying some test, some kind of test. Let's see how can we do that. So let's take a character. Since we are taking a matrix, we need those loops. This is for row and this is for columns. Sorry, we didn't declare ing. So this is essentially the code snippet for taking input of a matrix. So instead of scanning like %d or %c, you don't know what it will return. So C offers you getChar function which will read a character from the input and store it in ch. So as soon as you read a character, you will check. Now what are possibilities does this character have? It can be 0, it can be a, it can be 1, or it can be x. Only 4 possibilities. So let's take all the 4 possibilities into consideration. So what if ch equals to a? Now what do you keep over a? You should have one matrix. So we don't know the size, so let's hash define it. It's a 2-dimensional matrix of maximum length size, which is a macro of length 15. So at matrix of I, jth location, you will put ch. Now what will happen here is ch characters are essentially integers, which when we print it, it will be represented as a. So now what is the ASCII value of a? It is 65, right? So matrix of ij will have 65 in it. We don't care what value it has because we need to just have location. That means at 0, 0 there is Mr. A. So we need to know that at 0, 0 there is Mr. A. We don't need to know that is it is printed by capital A or whether it is printed by small a. That doesn't make sense to a program. So when you put here the value at matrix of I, j is 65. ch equals x, that is if it is the exit of the jungle. Now here also it doesn't matter whether you keep a or anything else, so you put ch as it is. So ASCII value of x gets stored here, so it will be something like 78 or something. Essentially just the ASCII value of x gets stored, we don't need to know. So here we need to keep track of a and the x, so we need to know the start index. Let's call it start x and start point, and also the end values. Now start x, what does start x have? We need to keep track of where a is. We'll keep a inside the matrix, but we don't know where to store that. So this represents the I, this represents j. Similarly, now see, now what all values does we can have? We can have either a, either x, or 0 or 1. 0 or 1 can be combined into a single case. Since if it is 0 or 1, we directly put that into the matrix. So only a single statement, we don't need curly braces. So we put ch. Don't has equivalent ASCII value. So suppose 0 as the ASCII value 50, then 50 will be stored in matrix again, but you don't want 50 to be stored, you want 0 or 1 to be stored. So from the ASCII value you subtract the 0 itself. So suppose ASCII value of 0 is 50, so here it's 50 and this is also character, so when you convert it into an integer, since in the expression automatically everything is promoted to an int before evaluating it in C language, so both will be considered as 50, so 50 minus 50 gives you 0, which is an integer and it will be stored in matrix again, which is essentially wanted. Suppose CH is 1, then it will be next value, so it will suppose it is 51. These are not the exact ASCII values, but suppose 1 has the ASCII value 51, then 51 minus 50 is 1, so our computation resulted correct since we verified it. One more thing we need to take care about the input is that when we enter A, we also enter space before entering 1. So you need to, when you take input character by character, you need to avoid spaces. So we need, whenever space is entered, you just decrement the J value and you'll say continue the loop again. Similarly, when you reach the end of the input line, we enter key, which is /n. So in C language, what happens when you take input from a file, /n and end of a line is repeated as two sequences, like it is repeated as /n and /r. End of a line is represented as a sequence like /n and /r, which is carriage return. So when end of a line comes, so you need to take care about all the not required values, which are space, /n and also /r. This is the problem encountered when you read character by character. You can read in any other way so that our problem doesn't get obfuscated. Our problem doesn't get even more complicated. So we essentially, if before checking all these conditions, we see whether CH is space or CH is /n or CH is /r. If it is any of these things, what do? We just skip the input, give me another input. So you don't just say continue, means it will continue, will take it to here, so it will increment J, which is wrong. We should not increment here, so we cannot change it here, so essentially we will decrement here, so the net result remains the same. Now okay, when you come here, the input will be ready, you will be having matrix ready. Now what we need to do is call a function. Suppose, let's say the function name is path exists. What we pass? You pass matrix, and you pass also the size of the board, the jungle, and also the start and end positions. You pass the start position so that A can be detected, you pass the end position so that when it reaches end you need to return back. So if that returns a function, what do you need to do? You need to print it true. Else you print false. So after the input is ready, we need to solve this function. So let's write a prototype here. So it's a boolean value, but C doesn't have booleans inbuilt, so you need to include the header which has the type bool declaration in it, which is called stdbool.h. So matrix, we are passing a two-dimensional matrix, an integer start value which represents the x, y position of Mr. initially, and this represents the x, y position of x capital X, that is exit of the jungle. Now you need to write the code for this. Now before writing the code, I said we need to keep track of matrix, which is visited matrix, visited array. Yeah, we forgot about the visited matrix, so let's give a declaration for it. So to make it global variable, since already we are passing many parameters. Now we need to initialize visited to all false, because once you call path exists, in suppose in another test case, when you are calling path exists, visited will have some means previously used values. So you need to make it before calling path exists. So you need to make visited initialize 0. So the classic initialization of an array can be done using a for loop or a while loop, iterate through all the elements and make everything a default value. Here we'll choose false, means if visited of I is false, the ith node is not yet visited. So we'll make everything false. We have a function string.h, string is included. This is called memset, and it will take 3 parameters. First is the array name. Second is the default value, which is false you want to initialize, and how many bytes, which is essentially size of listed. So this function does everything for us. We did not write a function. So in context, these things will be useful. So instead of writing a for loop, we just specify the name of the array and its default value for all its members and the size of the array. So visited will essentially become false and before calling. Now we call. Now we won't be using this end values of x and y because x is already fixed. So it's better to make it global. So okay. Now we call the function with matrix, the number of elements, the start end and x index. This you don't need to call with this since we declared globally. So it's basically you can declare, but thing is when you're computing path exists, you don't need index and end in every call. Like in our algorithm, since initially start will be at AS position, then when we go top right bottom left, it will go to 0. So we only need the x and y, start x and start y position. We don't need the index and y in every call. We do need, but it is better to keep it global and access it from there. Now in path exists, so what do we need to do is write the code. So when you call path exists, what do? You make this. When you call with this, you make it as true, so that I visited this. Now you need to go to top right bottom left order. So you say visited of x y is true. After making it true, you need to check all 4 cases. What are those 4 cases? There are north, east, south and west, all 4 cases. So how do we go? We go in clockwise direction, north, east, south and west, clockwise. It's your choice, but make sure you complete all 4 directions. So if you are going in top direction, that is in north direction, you need to check 3 constraints. First constraint is it must not go out of bounds. It must not go out of bounds. That means x minus 1 should be greater than or equal to 0. Means it must not pass this 0th index. So that is the first constraint. Not only one, we need to check many constraints. What is another constraint we need to check is the matrix position of x minus 1 and y should not be equal to 1. And that is the second constraint, because obviously you cannot move when there is an obstacle. And the third constraint is he must not yet be visited. He must not already be visited of that node. Like suppose Mr. is now here and he wants to go here. If he already visited that path coming from like this, he should not go, as we discussed just in the previous notepad. So visited of x minus 1. Oh, sorry, this visited must be two-dimensional array because why the visited must be two-dimensional array? Because for entire matrix you need to have visited matrix because matrix is two-dimensional. You need to keep track of all xy coordinates. So visited must also essentially be a two-dimensional matrix. X minus 1 y. So what does it represent? When you're going north, this x minus 1 should be strictly greater than 0, greater than or equal to 0, and you must not have a 1 over there, and you must not yet be visited. This not operator directly works because this is a boolean value. If it is true, it will become false. If it is false, it will become true because of this not operator. So if it is false, not yet visited, will receive true. So I will go into the test case. Now you need to check whether path exists. You need to call it recursively. No, path exists. Matrix will be as it is passed because it is base address represents. So the name represents the base address. So it will passed by. Then next is n. You need to pass. Then next is x minus 1. So here you need to take care. You need to call not by x comma y. You are going x minus 1. Y remains as it is. When you are going in northward direction, you are only changing x value. You are not changing y. You are only changing row. X represents row, y represents column. So you are only decrementing row by 1. You are not incrementing column. So if path exists means you'll say from here, if I can go above and there is a path exists, what do you do if there is a path exists? Means if suppose this recursive call returns true, what do you do? You will say return true. So if suppose this is not possible, you need to try all other constraints, right? This is north case. Now we are going east. When you are going east, you should not increment x, only see east represents this direction. Suppose you are here, suppose you are going here, so you need to increment only y, only column is increasing, row is not increasing, so only increment y. So y must be strictly less than n. Sorry, y plus 1 because you are moving right side. You will call recursively x comma y plus 1. Northeast. Now we will go south. When you go south, you are only incrementing x, not y. So when you increment it, should be less than n, and x plus 1 and y should not be equal to 1, and you will call it with x plus 1 and y. Now west case. Now what do you do in west case? Suppose you are here and you want to go west case. So you are only decrementing y, not x. X remains same, only y decrements. So y minus 1 should be greater than or equal to 0. X and y minus 1. So here are the recursive calls. So here you will take input, that is obvious. Taking matrix as input is not a big case. Solving these 4 cases, you need to get the idea. You need to recursively call all the 4 cases, and you need to keep track of 3 constraints for every if case. Like suppose one will be the out of bound case checking, and the other is the matrix case checking, that is it must not be equal to 1, and don't forget to make all the indexes correct. So because bugs will generally arise from there, and not yet visited also we need to see whether it is visited or not. So as you discussed, suppose if there is no path, when you backtrack, so you need to make visited false, because when you visited is declared globally, so when you backtrack, if none of the path exists, you need to mark visited of x comma y as false, saying that from here, from x comma y, I have no path to the destination. So you say visited of x comma y is false. This is important since it backtracks. So after all this case, we forgot to include two important checks. So what are they? When does this path exist return true? When you call this path exist, it will check everything. But did we ever check with index or end y, which you declared here, that is which we have initialized here? So when does it reach x? So before calling everything, we need to check here. After marking true, we need to check whether x matches index and as well as y matches end y. So what is this case? This is a base case of the recursion where everything ends. So here we need to return true. See, these are all the recursive calls, but these recursive calls should have a base case, right? So this is a base case which says whether I've reached end node or not. Now what is the failure case? When does it return false? When everything is not possible, so obviously you will say I can't do that, and you will say return false. So initially you will mark it as true, and you will check whether it is I reached the end or not. If it is reached, you will return true. Otherwise you will check all four possible cases, not this southwest, order is your choice. After that, if you come here, if you reach here anytime, it means that you couldn't have any path from all the above four cases. So you make visited as false and return false. Once you return false, this comes here. One more thing you need to keep in mind is you need to not output you should output slash n after true, but you should not output slash n after false, because false must be after true. See, first case is returns true, sample output. Second test case returns false. So after true you have false. After false you should not have a trailing slash n. So you need to remove the trailing slash n. How do you remove the trailing slash n? So here instead of true, let's write true and percentages. Now in percentages, what do? We'll take help of ternary operator. If t is 0, what does t indicate? Test case. When t is 0, that means if it is the last test case, don't print anything. Otherwise, print a slash n. So suppose test cases are 5. So when it will come inside the loop, it will become 4. So 4 equal to 0? No. So you print a slash n. That is, there is another print statement going to come. So essentially this is not part of the logic, but you need to take care of this in long languages, because sometimes your code doesn't get accepted because of this trailing slash n problem. Similarly for false, whenever you output something, if this is the last test case, that if it is last t equal to 0 means it is the last test case, you should not output slash n. So ternary operator will check this condition, and if it is true, it will return the first operand, otherwise it will return the second operand, which is slash n. So if it is last test case, nothing will get printed in percentages, otherwise the slash n gets printed. You can also write if else cases if this seems a bit pretty confusing, but this will do in this case. So now our code seems complete. Yeah, but one thing we are missing over here is we said to check all four cases, but because of else if north case fails, it skips all of this. Since if else if denotes that out of these four cases only one case exists, but according to algorithm, Mr. A must move in all four directions. All four directions possible according to the constraints. So instead of else if, we need to change it to if, because you need to move in all directions. If we keep else if, he'll move on in one of the four directions if it is possible. So now let's run our code and see. So yes, it's accepting all the tests. Now let's submit the code. So yes, now the status is accepted. So the problem basically reduces to finding the constraints. You need to find the constraint that Mr. A must be moving in off direction. Another alternate solution which you can do to this problem is you need to use stack. That time, if you are not good with recursion, you can use stack of C++. You can change the language of C++ over here and start using. You change the language C++ and you can start using this stack data structure. You need to just include hash include stack and just start pushing instead of calling recursively. So yes, this completes our problem height of laziness. Thank you for watching.